Hey, Rohini. Good evening. Let's wait for others for a couple of minutes, then we can start the session. Hey, everyone. Let's start the session. Can you see my screen? Vinay, Ashish, anyone? Okay, great. Cool. So today we'll talk about the probability. It's one of the very important thing for your statistics and data science modeling, right? So let's start with the very basic. What is probability? Anyone would like to answer based on your knowledge? I've asked you to study about probability in the last session, right? Can anyone wanna say something about it? Vinay, Ashish, Vaini, would you like to share your knowledge? Studied in school. Okay. So do you want to tell me like what is probability? I just want to check what do you know about the probability, right? There may be some confusions around it that we can clarify during the session. Okay, if you don't want to answer. Favorable event. Okay. I'm expecting it to be sample space, but okay. Cool. So let's start with the overview. Okay. So probability theory is the foundation of your statistical inference and predictive modeling, right? As I told you, right, the next topic in this series will be the statistical inferencing or inferential statistics, right? But before that, we should know about the probability first, right? Because we'll be using it a lot in that area, right? That's why we will cover all the required things in the probability. I'll try to cover most of them, and maybe you must be aware about some of the concepts because it's not new. It's all the basics, right? So how it helps? It basically helps you to quantify uncertainty, to make informed decisions based on patterns and likelihoods, right? So let's start with very basic concept of the probability. So I've asked you one question, right? What is probability exactly? Okay, so probability is nothing but it's a measure of how likely an event is to occur, right? So let's say I'm asking you to toss a coin, right? So what will be the probability of getting a head or tails, right? So that kind of things we try to quantify. It's just very basic example of getting trying to find a probability about a coin, right? To be head or tail, right? So how we express a probability, right? Uh, so can anyone tell me what is the continuous number? We studied about it in our first or second class. Any random guess? What is a continuous number? Vinay, Ashish, Rohini, Prashant, anyone? I told you, like when we were studying about it, I told you it'll be very helpful in future, right? So okay, let me simplify it for you. Okay, how many continuous numbers are there between 0 and 1? Any random guess? Vinay? Okay, nobody likes to answer. Okay, so as I told you, right? Okay, let me start with the very basic thing. What is the different? What is a continuous number, right? So a continuous number is nothing, okay, but you will have infinite values between two numbers. That basically is a continuous number, right? If we are talking about 0 and 1, you will have infinite possible continuous number, right? So even so probability, even we express probability between a number, zero, like using a number between 0 and 1. Okay, so let's say if I'm saying probability is 0.5, it means there are equal chances of occurring, so let's take example of a coin only, okay, and we talk about head and tail, right? I'm saying the probability of happening heads, right? It's 1.5, right? Then it means the equal chances are there for head and tails. Okay. We will talk about it in detail, how we calculate it, right? How we quantify it. But let's, be familiar with the terms, right? So if you're talking about zero, if you're saying the probability of any event is zero, it means this event will never happen. So it's kind of an impossible event, right? So let's take a very funny example. Okay, if I'm saying, right, what is the probability of sun rises in night or during night, right? Almost it's impossible, right? Not possible. Okay, so the probability of that is zero. So it's a impossible event, right? And if I'm saying the probability of something is one, it means it's a certain event. It's gonna happen. Okay, sun will rise in morning, right? There's no chance, right? It will not rise in morning. Okay, and unless NASA is shooting the sun outside of the world, right? Or maybe some unfortunate event is happening, that's highly unlikely, right? So any certain event, right, that is gonna happen, we represent that by probability one, and one is the maximum that you can get, because as I told you, the values of probability will lie between 0 and 1. Okay, and probability is a continuous number. Okay, between 0 and 1. Okay, so it means there are infinite choices for a probability between 0 and 1. Okay. Any doubt so far?
No.
Right. Don't want to speak, you can write in chat. Okay, when you are having an internet issue.
Yeah, I had internet issue. Now it's clear.
Great. Okay. So let's discuss few real life examples. I gave you few, but let's discuss some of them. So flipping a fair coin, right? So by fair, I mean in this case, no side of the coin is biased, right? So generally, when we used to play cricket or anything, right, any sport, we used to toss a coin, right, and we used to keep our lucky coin, right? So in that scenario, we used to get a lot of tail, a lot of head, right? So that coin was not fair. By fair coin, I mean the chances of getting head and tail are equal. Okay, so it's a fair coin. So what will be the probability of getting heads, right? So we'll talk about the sample space as well. In this case, the sample space is either head or tail, right? And either way, like you will get only one head in a coin, right? Like if you toss it, either you'll get head or tail. So if I'm talking about head, so number of trial will be one, number of favorable outcomes, right, will be one, divided by total number of possible outcomes. So in this case, we have total number of possible outcome is two. Okay, so the probability for that will be 1/2. So that's why we are having it zero point 0.5 here. Okay. Don't worry if you're not able to understand how we are calculating it. We will be talking about it in detail. Okay. Similarly, rolling a fair six-sided die, right? So what will be the probability of getting a six? It'll be 1/6, right? If you have any doubt how we are getting 1/6, don't worry, we'll be talking about it. Okay. Uh, so let me give you a very a real life situation kind of example, weather forecast. So must have read about it in news in your phone, right? There are 80% chances of rain today. Okay, so what does it mean? It means maybe like considering the weather scenario, 8 out of 10 similar situations, resulted in rain. So, right, if you check the weather and all, right? So, with that thing, right, you are certain, right? Because it happens 8 out of 10 times. So, probability of getting of rain on that day is 80% because the weather conditions are one of them. I mean, among the favorable outcomes. Okay. So now let's talk about the very basic thing, the formula of probability. Okay, so probability for an event A will be the number of favorable outcomes for that events divided by the total number of possible outcomes. Okay. So any doubt here? So it's not an easy topic, I agree. But if you have any doubt, we'll keep it interactive. Okay. So today it's very important. Okay, so I want your maximum attention today and maximum participation. We'll be solving a lot of examples as well, right? Great, no doubt till now. Yeah, but I want everyone to participate today. Okay, it's an interesting topic, and if you miss anything, right, you'll not be able to understand it. So better be focused and ask as many doubts as possible. Okay, let's move to the next slide. Okay, so let's familiar with the probability terminology, right? So if you are familiar with the all the terminology, right, it'll be easy for you to understand a probability question. Okay, so what is the experiment or a trial, right? So it's a process or action that results in an outcome. Okay, so examples can be rolling a die. Okay, it's experiment or a trial. Okay, flipping a coin, right? Again, it's experiment or a trial, right? Drawing a card from a deck. By deck, I mean the playing cards that we use. Okay, cool. So this is one of the important terminology, right? Because you'll be getting a lot of similar kind of things, right? I have there are n number of trials for some experiment. Like there will be a lot of sentences like this in the questions that you will find right at the end of this session. Okay. So now the second important thing in this is sample space. Okay. So you must have remember, like I took one example of sample space when I was talking about head and tails, right? So for rolling a die, right, or rolling a fair six-sided die, so how many possible outcomes are there, right? So if you talk about a die, only six sides are there, right? So one, two, three, four, five, six are the possible outcomes of rolling a die. Okay. Any question here? Similarly, if you flip a coin, how many possible outcomes are there? A coin can be either a heads or a tail, right? So in this case, the possible outcomes for flipping a coin will be heads and tails. Any doubt till now in the in experiment of sample space? Okay, yeah. Let's move to the next slide. Okay, so third important thing is an event. Okay, so it's one of the important thing if I talk about. Okay, so event is a subset of your sample space containing one or more possible outcomes. Okay, so let's talk about, let's take a very simple example. It's one first example in this PPT. Okay, rolling an even number on a die. Okay, so what are the even numbers on a die? So we have total six numbers on the die, right? One, two, three, four, five, six, right? So out of those six, how many are even? Only three, right? Two, four, and six. So it means in this example, right, what will be the event in this case, right? So it'll be either 2, 4, or 6, right? So if I say what will be the probability of getting even number if I roll a even if I roll a die with six-sided face, okay, and again it's a fair die. Okay, so we read about the formula of probability, right? That was nothing but the number of favorable outcomes divided by the total number of possible outcomes. So in this case, how many favorable outcomes are there? Three, two, four, or six, right? And how many possible outcomes are there? Six, right? So what will be the probability of getting an even number from a six-faced fair die? Is will be 3 divided by 6. So the final answer will be 1 by 2 or zero point 0.5. Understood? Any doubt? So all questions are gonna be like this only. Okay. So let's take second example. Okay. drawing a red card from a standard deck, right? So I think all of you know about this, right? How many cards are there in a deck, right? 52 cards are there in the deck, correct? And we have, four different type of cards there. Okay. So we have spade, diamond, club, and heart, right? Four different types of card there, but only two colors, two type of colors, right? So 26 cards are red there, and 26 cards are black. So in this case, I'm asking you to, asking about the probability of drawing a red card from a standard deck. So by standard means it's not a special deck, right? Each card will be having the similar probability. Okay. So if I say I want you to find out a red card, so in this case, how many favorable outcomes are there? Or let's talk about the event, right? So you have 26 red cards. It means you have 26 favorable outcomes, correct? Right? What are the total number of possible outcomes out of one deck? Like you have 52 cards, you'll be having 52 total outcomes, correct? So the probability of getting a red card will be again 26 divided by 52. That is nothing but 0.5. Okay. Now let's talk about probability of event that we have already studied while talking about the event only. Okay, let me repeat it again so that you understand, right? So the probability of event, it's nothing but a likelihood of event occurring, right? So we just talk about, right, rolling a fair die and getting a card, red card from the deck. So let's solve two more examples similar to that. Okay. So in this case, first example is rolling a 4 on a fair six-sided die. Okay. So the favorable outcome for 4 is 1 only because, right, out of total number of possible outcomes, how many times 4 can come, right? Only once, right? Out of that 6, only 4 is coming only one time, right? So the favorable outcome is 1. And what are the total number of possible outcomes? They are 6 in this case. So the probability will be P of 4 will be probability of getting that event, right? A here, we are representing A with the event, okay, or event with the A. So here probability of getting a 4 is 1 divided by 6. Okay, that is nothing but 0.1667. Okay, and you can see, right, we are getting a continuous number, correct? As I mentioned, the probability, the outcome of probability will be a continuous number between 0 and 1. Okay, any doubt? See, it's a very interesting concept if you want to understand logistic regression while reading and studying the machine learning algorithms. If you don't know about probability, right, it'll be very difficult for you to understand the logistic regression algorithm because there we use probability concept and it's very important. Okay, in many scenarios we'll be using probabilities, right? So that's why we are studying probability during a statistics lecture. Okay, so it's very very important, so please focus. Okay, and try to take part while I'm answering question or asking, right? Okay, let's talk about another example. Okay, so now the next question is, or the next example is drawing an ace from a deck of 52 cards. Okay, so can anyone tell me how many aces are there in a 52 deck cards, 52 cards deck? Four, great. Okay, so in this case, what are the favorable outcomes? Here we are talking about the aces, right? So only four aces are there out of the 52 deck cards, right? So correct answer, Prashant. Right. So the favorable outcome will be 4 and the total number of outcomes will be 52 in this case because we have 52 cards in the deck. Right. So the probability will be 4 divided by 52 will be 0.0769. Okay. Any doubts so far? And Prashant, thanks for taking part. I want all of you to, at least answer in chat, right? If you're not able to turn on your speaker and answer. Okay. Okay. So let's summarize it. What we studied so far in the probability terminology, right? We talked about experiment, right? It's a process that leads to an outcome like rolling a die, fetching a card from a 52 card stack, right? Tossing a coin, right? Sample space. Sample space is nothing but the total number of possible outcomes, right, from an experiment. Okay. So event is nothing but it's a subset of your possible outcomes, right? Or a sample space. Okay. Probability of event, the likelihood of event occurring. Correct? And how we calculate the probability of event? P of A will be favorable number of favorable outcomes divided by the total number of outcomes. Okay. Can we move to the next section? All of you are, clear? Any confusion? If you have any, please let me know. Okay, Vinay, is this yes for no confusion or you have a confusion?
No, it's clear. It's clear. Good to
Okay,
go.
great. Anyone else? Okay, I guess I'm taking this as a no. Okay, let's move to the next part. Okay, great, Prashant. Okay, now let's solve a problem. Okay, see, it'll be like probably that. Okay, we have already studied almost all the theory in this topic. Okay, that was the only theory, right? What is probability? So in this session, we'll mostly be solving examples, and I'll tell you a lot of other tricks, formulas, right? How to solve probability questions. Okay, so it's gonna be a practical session, right? And let me know if you want any explanation or anything. Okay, so let's solve another example. Okay, rolling a die. Okay, let's say we are rolling a die, and I want to know about the probability of getting a three. Okay. So what are the favorable outcomes to get a three out of, while rolling a die? Okay. So the sample space, right? Sample space for rolling a die is 1, 2, 3, 4, 5, 6. Okay. How many times 3 is coming in that sample space? Only one time, right? So what are the favorable outcomes for 3? Only one, right? So numerator will be 1 because we are talking about the favorable outcomes here, right? And divided by the total number of possible outcomes. So in this case, total number of possible outcomes are 6. So what will be the probability of getting a 3 is 1 divided by 6. Okay. Again, I think we have already solved this question. The probability of rolling an even number. Okay. So the total number of favorable outcomes, right? Because out of 6, we only have 3 even numbers. There are 2, 4, and 6. Okay. And the total number of possible outcomes that are 6. Okay. So what will be the probability of getting an even number? It will be 3 divided by the 6. Okay. So final answer will be 0.5. Okay. So now I want all of you to answer the question that is available on your screen. What is the probability of getting a number greater than 4 when rolling a die? Okay, you have 3 minutes to solve this question. I want everyone to participate. Please answer this question. It'll help you to check your knowledge, like how much you have understood so far. Okay, thanks for the answer, guys. Okay, let's try to solve this. Okay, so what are the favorable outcomes of getting a number greater than 4? And here we are talking about rolling a die. Okay, so first of all, let's talk about the sample space, right? Sample space for rolling a die will be 1, 2, 6 only, 1, 2, 3, 4, 5, 6, right? And now let's talk about the favorable outcomes out of the sample space, right? Or basically the event, right? That's our target. Event here is getting a number greater than 4. Okay, so how many numbers are there greater than 4? 5 and 6. Okay, so what are the total number of favorable outcomes? 2. And the total number of what possible outcomes? 6. So the final probability of getting a number greater than 4 will be 2 divided by 6. Great job, Vinay. Answer is right. So the answer is 2 divided by 6, 1 by 3. And same for Prashant. It's 1 by 3. Great. Thank you. Okay. Ashish Rohini, you have any doubt? Okay. Okay. So let's move to the next slide. Okay. So let's talk about a relative frequency. Okay. So it's nothing but almost the same concept, right? But sometimes you can hear about it, right? Maybe instead of asking the probability directly, people can ask you about the relative frequency. Okay, relative frequency is nothing but an experimental probability based on the observations. Okay, so it estimates the probability of event by conducting repeated trials. Okay, so the formula for the relative frequency will be number of times event occurs divided by the total number of trials. Okay, so let's take example. So it's a coin toss experiment, right? So the example is if you toss a fair coin 100 times and get heads 48 times. Okay, so the relative frequency of head is right now. Okay, that's it's a very interesting concept. Okay, so here, like what we have studied so far, right? If we are talking about a fair coin, right? So the probability of getting either a head or tail will be 1 divided by 2, right? Zero point 0.5, right? But here they have not mentioned that, right? Like based on the trial, right? We try to find out is it a fair coin or not. Okay, they have mentioned if you toss a fair coin 100 times, right? So ideally the getting of the probability of getting heads, right? If I even if I'm tossing it thousand times or 10,000 times, it should be zero point 0.5 or close to zero point 0.5 if it is a fair coin, right? So that's what we are trying to conclude here. So P of H, right? P of probability of getting head will be 48, right? Because the number of time that event occurs, number of time we get heads, right, was 48, and the total number of trials, right, was 100. So the final probability is 0.48, right? Any doubt? Okay. So now I have a real life activity for you. You can try if you have time. Not now, right? You all are having you all must be having one coin at least at your home, right? So what you can do, you can try the same experiment instead of trying 100 times, right? You can try it 10 times. So theoretically, you will the probability of getting either a head or tail is zero point 0.5, right? Let's see the coin that you are having is fair or not, right? So you can toss it 10 times and check, right, how many times you get the heads or tails, right? And try to calculate the probability of getting the heads. The similar exercise. It's for fun. If you want to do it, you can do it. Otherwise, ignore it, right? So I used to love these kind of activity. I want to try how is it possible? Okay, so it's a great or it's a good fun activity. You can see it in real life, right? Most of the time we are not able to see the mathematical stuff happening in the real life, right? If I talk about differential equation, integration, right? Real life it's difficult, but we follow a lot of things nowadays and we use these concepts, right? But probability is something that you can do in your real life. Okay, now let's move to the next part. Okay, now let's talk about types of probability events. Okay, but first let me ask, do you have any doubt so far? Okay, Vinay, no. Okay, great. Let's move. Okay, so events in probability can be classified into multiple types. Okay, there are four. I'll explain one by one. Okay, so first is independent event. Okay, can anyone wanna have a quick guess what are the independent events? I'll be taking real life example as well so that you get the idea what are the independent events. But let's talk about the definition of independent event according to the book or theory, right? So independent events, when you call two events are independent, right? If the occurrence of one event does not affect the other. Okay. So let's say I am saying it's gonna rain today, okay, and I will uh, not like it's not a good example. Okay, I'm gonna eat the food and it's gonna rain today. Okay, are these two events related to each other? Because like obviously I'll be having food daily, right? If I'm not keeping fast or something, right? It doesn't matter if it rains or not. I'll be having food. So these two independents are so these two events are independent of each other. Okay, so if you are not able to understand, if you have any confusion, let me know. Okay, so Again, let me repeat, two events are independent if the occurrence of one does not affect the other. Okay, so let's take a example. Okay, flipping a coin and rolling a die are independent. Okay, since the outcome of one does not change the probability of other. Okay, so if I'm saying what is the probability of happening, rolling a die or getting a heads and getting a six, right? Like these two happen, events should happen together. Okay, well, what is the probability of that? Okay, so so here we say A intersection B. I'm assuming you all are aware about the sets, right? Is my assumption correct? You all are aware about the set theory? Okay, great. Okay, so probability of these two events happening together, what will be P A intersection B? Basically, we are trying to find out the overlap of these two sets, right? So the formula for checking this is P A intersection B is P probability of A multiplied by probability of B. Okay, so how we calculate the probability of getting a head and a 6 while rolling a die. Okay, so first let's calculate the probability of getting a head. We all know it's 1 by 2, right? And probability of getting a 6 out of a 6 faced die is 1 by 6. I don't have to tell you, right, how to calculate this. We have already discussed about it two times. If you have any doubt, you can nudge me. Okay, so now what is the probability of getting a h and 6? Okay, so it will be the multiplication of 2, 1 by 2, the probability of getting a heads, into 1 by 6, the probability of getting a 6. The final answer will be 1 by 12. Okay, now let's move to the next type of event, that is the dependent event. Okay, so what is a dependent event? Can anyone wanna take a guess based on the uh, you know the last example we took, or the last event we discussed?
Shall I tell in terms of dice, like getting a number like one? What's the probability of getting one, and what's the probability of getting five? Both are dependent. Uh,
Mm-hmm.
yeah,
Uh,
is that fine?
So these two are independent events, right? Let's take let's pick any two number out of a dice, right? 2 and 6 are not dependent on each other. Okay, let's say if in the first trial I'm getting 2, right? I cannot say that in the next trial I'll get a 6, right? Because these two are independent event, right? I'll tell you, right? I'll take a very good example. Okay, like how two events are dependent. Okay, so let me tell you the definition first. Two events are dependent if the occurrence of one event affects the probability of other. Okay, so let's discuss the same example that Vinay mentioned. Okay, so a die, getting a number from a die, let's say 2, is not dependent on getting a number from getting a 6 from a die, right? Because nothing is changing, right? Even if I'm getting 2 in the first trial, right, it will not affect the probability of getting a 6, right? So these two events are independent, but here we're talking about a dependent event, right? So let's take example of a card deck, right? So let's say if I'm saying what is the probability of getting a ace from a deck, right? A 52 cards deck. Okay, it'll be 4 by 52. We already discussed, right? In our last examples. Okay, but here I have mentioned one thing. Okay, drawing two cards from a deck without replacement. Okay. Now what will happen if let's say if in the first turn, I have already removed one card that was an ace, right? So what will be the probability of getting a king now, right? Now you are left with only 51 possible outcomes, right? It has affected the total possible outcomes, right? So the next event is dependent on the previous event, correct? Any doubt here? Okay, I'm assuming no doubt. Okay, so we represent that, right? Probability of happening an event if a event has already occurred, right? So in this case, if you see the P B by A right here, this one, let me see if I can use the pointer. Okay, is pointer visible to all of you? So I'm talking about this. Okay. So this is the probability of event B when event A has already occurred. Okay. So in this scenario, it is the probability of getting a king when event A, getting drawing ace has already occurred. Okay. So how we calculate the probability of dependent events, like these two event happening together, PA intersection B, it is probability of your event A into probability of event B when A has already occurred. Okay. So now can anyone tell me what will be the probability of drawing two queens from a deck? Okay. You can use this example to solve it. You have 3 minutes. Try to solve it. See, I want you to answer this question. If you are not able to, I'll explain again, right? I want you to understand this concept properly. Okay, take your time and try to answer. Vinay, Prashant, Rohini, Ashish, anyone would like to answer? Or
Do
you
we
need
need to give like for the first queen and second queen separately or together?
obviously separately, right? Because there are two events happening, right?
Then
So
it will
first,
be like 4 by 52 and 3 by 51. Correct.
right. So what will be the final answer of drawing two queens from a deck? Right? It'll be 4 by 52 into 3 by 51, Vinay, because we have already drawn one. Okay, if you have any doubt, you can ask me. You got it? Okay. By the way, thanks for answering. I want everyone to participate. Great. So I'm assuming no one have any doubt about this dependent events. Okay, let's move to the next topic. So third is mutually exclusive events, right? So two events are mutually exclusive if they cannot happen at the same time. Okay. Any doubt in the definition? So when you were asking right that question, I like kept it on a hold, right? I have not explained it properly because of this particular reason. Okay, this can answer your question. Okay, so example, rolling a die, right? You cannot get both 3 and 5 at the same time, right? So what will be the probability of getting a 3 and 5, right? Together, like one after another, right? Because these are two events we're talking about, right? So again, it's very simple. So it is about P A union B. Okay, because we want like them to happen together, but they are not either independent or dependent, right? So how we'll calculate it? First of all, you have to identify, right? What when you are like trying to solve something, right? You have to identify what kind of event it is, right? So any doubt like in identifying it is an independent event or a dependent event, right? Let's talk about these two events first, right? You all understood, right? How to identify an independent event, right? So in case of independent event, when will you say that the even two events that are happening are independent of each other, right? So the occurrence of one does not affecting the another. It means they both are independent events. Okay, so that's how you will identify it, right? Similarly, how will you say or when will you say if two events are dependent, right? So it means one event affects the probability of other. So let's say drawing two cards from a deck, right? So when you draw first card, right, whatever it is, it will affect the probability of your next card, right? Understood, right? So that's how you identify a dependent event. Okay. So now, like, let's talk about the third type of event, that is mutually exclusive event. Okay. So mutually exclusive events are like events that cannot happen at the same time, right? You cannot get 5 and 6 or any two different numbers, not identical number, any two different numbers from a single die, right? You can roll it once only, right? You will have one number on the top, correct? So probability of getting 3 and 5 are not, I mean, the event 3 and 5 are not happening at the same time. But I want you to know the probability of happening these two events together, right? So we represented PA intersection, A union B, uh, and we how we calculate it is the summation of probability of happening event A plus probability of happening event B. Okay, so now let's try to solve this example. Okay, rolling a die and getting a 3 and 5 at the same time. Okay, so first we will talk about the probability of getting a 3. And this 1 by 6 because 3 comes only once in the sample space, right? And what is the size of sample space? In case of this, is 6. So for both 3 and 5, the probability will be 1 by 6. How will you calculate the probability of 3 and 5 happening, right? One after another, right? So it will be 3 intersections, 3 union 5, and the final outcome will be 1 divided by 6 plus 1 divided by 6. That is nothing but the probability of 3 plus probability of 5. So final answer will be 1 divided by 3. Any doubt? Okay. See, don't worry about the time, right? If we are not able to finish this session in today's class, we will take extra class tomorrow. Not tomorrow. I mean, we can extend it in the next session, right? Because next session is, I mean, we'll be discussing about the distributions, right? And for that to understand, you should know each and everything in the probability first. Okay, let's move to the next type of event, that is nothing but the complementary events, right? So complementary event, okay, anyone wanna take any random guess based on the definition? Anyone? It's very simple. So the complement of an event A is the probability that A does not happen. So it's the negative of something, right? Uh, so let's say the probability of not rolling a 6 on a die. Okay. So what will be the probability of not rolling a 6 on a die? So out of the sample space, okay, what will be the probability of not getting a 6? Can anyone tell me? Okay, the simplest answer is 5 divided by 6. We can tell directly, right? We can just pick, out of the sample space, we can say, okay, out of the 1, 2, 3, 4, 5, 6, how many times like other numbers are coming data? 5 divided by total number 6. But if you want to calculate the complement directly, P not 6, right? So total probability is 1, we all know, right? We discussed at the beginning only, right? So 1 minus probability of happening 6, right? So what is the probability of happening 6? It is 1 divided by 6. We all know how to calculate it, right? So what will be the probability of not getting a 6 is 1 minus 1 by 6 will be equal to 5 by 6. So we generally represent not 6 by A bar or A naught. Okay. So probability of A naught will be 1 minus probability of A. Okay. Any doubt in the formula? Okay, so now let's try to solve this question if you are not having any doubt. Okay, so the question is, if the probability of happening rain tomorrow is 0.3, what is the probability that it won't rain tomorrow? It's a very simple question. Try to answer it in like one shot. You have 50 seconds to answer this. Try to answer, everyone. It's a simple question. We just discussed how to calculate the complementary event. Great, Prashant. Okay, so the answer is 0.7. And how we land up on this answer? So probability of not happening rain will be 1 minus probability of happening rain, right? Because it's a complement of that, right? So the final answer will be 1 minus 0.3, that is nothing but 0.7. Okay, any doubt? I guess no doubt. Let's move to the next slide, right? Okay, now there are some rules and theorems, right? Okay, but first let me know if you have any doubt in the topics that we have discussed so far, because these things are dependent. If you're not answering, I'll be taking this as a yes. You don't have any doubt. I'll move further. Okay, cool. So first is addition rule or events, right? Or events, you know, na, right? Either this or that. You use or and a lot, right? Any doubt? Okay. So probability of happening A or B will be, okay, these are the rules and theorems in the probability. You should memorize this, right? So the addition rule, right, for all events, probability of happening A or B will be P of A plus P of B. It means probability of A plus probability of B minus P A intersection B. A intersection B, you remember, like we discussed. Okay. Okay, you don't want to answer that. Okay, cool. So probably let's try to solve the example. You'll get the idea. Okay. Drawing a red card or an ace from a deck. Okay. So what is the probability of getting a red card? Right? So how many total red cards are there in the 52 cards deck? 26, right? So these are our favorable outcomes. So the favorable outcomes are 26. Divide by the total number of possible outcomes. So total number of possible outcomes for us is 52. Okay. So the probability of getting a red card will be 1 by 2. Okay. Now let's talk about the probability of getting an ace. Okay. So keep that in mind. It's a or event, right? Either this or that. Okay. So probability of getting a ace, because we have not drawn any card so far, right? So the probability of getting an ace will be, there are 4 ace in that 52 cards deck, right? So what will be the favorable number of outcomes? It will be 4, right? 4 divided by the total number of possible outcomes. Total number of possible outcomes in this case is 52. Okay. So the probability of getting an ace will be 4 divided by 52. Okay. Now let's solve an interesting piece. Okay. Probability of getting a red or this and ace, right? We talk about it like probability of getting a red and a ace, right? So first of all, tell me, getting a red and ace, right? Are these independent, dependent, or what kind of events they are? Or getting these, first of all, getting these two together. Okay, let's move a little back. Okay, I want you, all of you, to understand that concept. Okay, first of all, try to identify what kind of event it is. Okay, and this is a homework for you guys. Okay, because I've asked everyone to understand these things, right? We will definitely be discussing this in the next class, but I want all of you to, try this. Okay, try to understand what are the event, like, okay, first of all, you have to, understand, right, how to identify an event. It's very, very important. If you're not able to differentiate between the type of events, it will be very difficult for you to solve a probability question. Okay,
Like last example was dependent, no?
which one?
That where we are taking out the ace cards and the red cards. The examples,
So
what you
it's
are
an
talking
or question, right? Prashant,
about.
right? Okay,
Okay, okay.
either red or either ace, right? So we are not drawing anything from the deck, right? So getting a red or getting a ace is a totally independent event, right?
No, but it will be taking from the ace. Ace is also in there in the red card also, no?
Okay. So first thing is
In the diamond and the heart also ace is there, no?
no, no. See, you okay? I think you missed it. When I say right, drawing a red card or an ace card from a deck, right? Or what does odd or mean here? Right? Either the event, I mean the first event or the second event, right? So it's not impacting each other. You
I
try.
thought like a red card and ace card. That's
Yeah.
where I
It's
mentioned.
not
Okay,
and,
okay,
it's
I got
or.
it. Yeah, I got it.
Okay. So I want all of you to calculate the third thing, P red and intersection A's. Okay, it's your homework. Please note it down. Take a screenshot. Okay, I want you to solve this, and I'll be discussing it in the next class. Right? I want all of you to answer this. Okay. So for now, I am taking the final probability that is 2 by 52, but I want all of you to calculate this. Okay. So how will you calculate P probability of happening either A or B? Okay. Prashant, it's not a die, it's a we are talking about deck here. Okay. You can try it home. I mean, we will not be discussing it right now. Okay. It's a homework for you guys. Okay. And I have few more questions for the homework, right? I want all of you to answer, and we'll be discussing that in the next session, at least for 30 minutes. Okay. So now let's put all those values in the formula that we have, the addition rule. P of happening either A or B. Here in this case, A is drawing a red card, B is getting an ace from the deck. Okay. So let's put it. So P of A is or P of red is 26 divided by 52. P of ace is 5 divided by 52. Okay. Minus P of red intersection ace. Okay. That is nothing but 2 divided by 52. The final answer is 0.538. Okay. Now let's move to the next rule, multiplication rule. Okay. We'll be solving a lot of examples, right? You will get the idea, right? Like how we are doing it. But okay, try to imagine it first, right? Or try to memorize it. If you have any doubt, let me know. Okay, I'm assuming you don't have any doubt. Okay, so let's move to the next rule, that is the multiplication rule or the AND events. Okay, so what is the probability of happening two events together, the independent events, right? PA intersection B. We just studied, right? Independent events, right? So probability of happening two independent events are P of A into or P of A multiplied by P of B. Okay. Any doubt here? And let's and we will discuss this addition rule in detail again. I think you have some doubt. I'm getting that feeling. Okay, we'll be discussing that. Okay, but you can hold it for some time. Okay, let's talk about okay, the next thing is the conditional probability. Okay, but I think I should discuss that. Okay, how many of you want to like listen about addition rule again? If you have any doubt, I can
Yeah,
repeat it.
can you please explain me? Actually, I missed it due to some call. Sorry.
Okay, cool. Okay, So let me give you the idea of it. So addition rule for, first of all, like there we have discussed about three types of events, right? Four types of events basically. Okay, let me go back. Okay. One was the independent event, right? You know what are the independent events, right? Other one was the dependent events, correct? And third one was the mutually exclusive events, right? So what are the mutually exclusive events? Right? The events that cannot happen at the same time. Okay. Now let's talk about the addition rule. Okay, so the addition rule formula that I'm saying is P probability of happening A and B, either A or B, is P of A plus P of B minus P A intersection B. Okay, so if we are saying A and B are mutually exclusive, okay, keep this in mind. If we are saying A and B are mutually exclusive, it means the probability of happening these two events together will be, I want all of you to answer, will be either zero or what? Can anyone answer using this definition? It'll be zero, right? Because we are, if we are saying the A and B are mutually exclusive event, right? So the value of P intersection B, right, happening these two events together will be zero, right? Because A and B cannot happen at the same time if event A and B are mutually exclusive, right? So in that scenario, the probability of happening either A or B will be P of A plus P of B. Okay. The simplest example we can, okay, when I left, I was repeating for him only, but it's okay. I'll complete this. Okay. So the probability of, okay, let's take one very nice example, rolling a die, right? And getting either A or, sorry, getting either 2 or 5. Okay. So are these two events are like mutually exclusive, independent or dependent? Getting 2 or 5? Can anyone answer? See, as I told you, like the most important thing is to identify the type of the event, right? Now we are talking about getting 2 or 5 from a die. Okay. So first of all, to solve this problem, we have to identify what kind of event it is, right? So it is a mutually exclusive event, right? Because 2 and 5 cannot happen together, right? You can get only one number out of a die, right? So probability of happening or getting 2 and 5 together is zero, correct? So in this formula, P of intersect A intersection B will be zero because these two events cannot happen together. So the final answer will be P of A plus P of B. In this case, what is the probability of P of A, or what is P of A here? It is P of 3. Okay, getting a 3 from the die, that will be 1 divided by 6. P of 5, that is the getting a 5 from a die is again 1 by 6. So the answer will be 2 divided by 6. The final answer will be 1 by 3. So this is the addition rule. Okay. Now let's try to solve it for a non-mutually exclusive event, right? Now these two events can happen together, or you can call them as the overlapping events. Okay, so let me explain it in detail. So when two events can happen at the same time, right? They are not mutually exclusive. By the definition we are going, right? So what does non-mutually exclusive event? When two events cannot happen at the same time. You all got it right? What is the not mutually exclusive event, right? Okay. So now in this case, right, when it is not mutually exclusive, right, it'll not be zero. You'll be having some probability of happening these two events together, right? So we have to, basically see now it's a, yeah, I need, okay, let me try to, explain it using a pen here. Okay. So we have this circle. Okay. Of, this is the chance of happening A. Okay. Event A. Okay. And we have another circle that is nothing but chances of happening B. And sorry for my handwriting. Okay. Now, like we have this section that is overlapping, right? In this case. Okay. I want to calculate the probability of happening either A or B, right? So to calculate that, I have to remove this section from this probability, correct? This overlapping section. All of you are with me? This overlapping section I'm talking about, right? So if we add this P of A plus P of B, so we have to, remove this section because we are saying either A or either B. I don't want to, have both of the events happening together. That is this particular section when they are overlapping with each other, right? So here, why they are overlapping? Because these two events are not mutually exclusive. They can happen at the same time, right? So there will be some overlap. Okay. So to calculate this probability of happening event A and B, either A or B will be either P of A plus P of B minus P of A intersection B. P of A intersection B is nothing but the probability of happening these two events together. All of you understood? Any doubt here? Okay, cool. Now let's solve this example again. Okay, so now what is the probability of getting a red card? You all know this 26 by 52, right? What is the probability of getting a ace? That is nothing but 4 by 52. Okay, so now the probability of getting up. So okay, now let's try to identify, right? Now what I'm trying to say, right? Probability of happening event A and B together. It means here we are saying probability of getting a rad ace. Okay, so or we can put it another way. What is the probability of getting a red card and it's an ace? Okay, so how many red aces are there, right? It could be either a hearts, ace of hearts or ace of diamonds because we only have two types of red cards, right? Hearts or diamonds. So what are the favorable outcomes in this case? 2 divided by the total number of cards, right? That is nothing but 52. Okay. So we will put all these values in the formula, right? So what is P of A here? 26 by 52 plus P of B, that is nothing but probability of getting an ace, 4 by 52 minus probability of happening these two events together because they are non-mutually exclusive event, right? So it's nothing but minus 2 by 52. So the final answer that you will get it is 0.538. Okay. Any doubt so far? Because this is very important to understand the next, uh, you know, problems or the next concepts. Okay, great. Okay, so I would like to repeat the second rule as well. That is nothing but the multiplication rule, right? So probability of happening A and B together if they are independent events. So it is P of A into P of B. Okay. You guys know why we are doing it for the independent events only. Okay. Okay. Anyone would like to solve this? Find the probability of rolling two dice in a row. It's very easy. Think 1 divided by 6 into 1 divided by 6. It's okay. Okay. Now let's move to the conditional probability. Okay. So first of all, I would like to ask any doubt so far. We can still go back. Ashish, Prashant, Rohini. Okay. Thanks, Prashant, for answering. Okay, cool. Let's move to the next concept, that is the conditional probability. So conditional probability measures the probability of event A. Try to understand it, right? And listen carefully. Conditional probability measures the probability of event A occurring given the event B has already occurred, right? We talked about similar thing when we were trying to solve the example, right? Earlier it was P of B divided by A, right? When we were trying to say probability of happening B or occurring event B when A has already occurred, right? Similarly, we are trying to calculate this. Okay. So here we are trying to say probability of getting occurring event A given that event B has already occurred. Okay. If anyone has any doubt to understand this definition, please let me know. Okay, I'm waiting for your answer. Okay, Vishant. Thank you. Okay. So how we, let's talk about the formula, then I'll come to the explanation part again. So probability of event A occurring, that event B has already occurred. First of all, we try to represent it by PA slash B, A by B. So here what we're trying to say, probability of event A occurring when B has already occurred, right? So how we solve it? So probability of happening A and B together, right, divided by the probability of B. Okay. All of you should be, able to identify like what kind of like event or the probability we're trying to calculate here, right? So it is nothing but the probability of A and B happening together and divided by the P of B. Okay. So let's try to solve a question. Okay. Or first of all, let's try to understand it with the example. Okay. So let's take example of medical testing. Okay. So here we are saying 2% of a population has disease X, right? And test for the disease is 90% accurate, true positive rate. Okay, so here I'm trying to basically relate your machine learning concepts, right? How will you use this in your machine learning classes, right? So these things are very important. We'll move to the next algorithm as well, that is nothing but the Bayes theorem, and that is again a very important concept. Okay. Okay. So here we're saying a test for the disease is 90% accurate. Okay, that is nothing but the true positive rate. Okay, so let's try to, understand what we are trying to say here. So what is the probability of a test to be positive, right? It is 90%, right? That is nothing but 9 by 10. Okay, it's nothing but 0.9. Okay. Now the question is, but we will not solve it just now. We are just trying to formulate it, right? We will be solving it in the next upcoming slides. Okay. Given that a person test positive, okay, what is the probability they actually have the disease? Okay. We'll be solving it using the Bayes theorem because it's related to that. But I was trying to, put the ideas in your mind, right? How these things are related. Okay, now let's break it down. Okay, first we saw three things in the conditional probability formula. First was probability of event A occurring given B has already occurred. Okay, P A intersection B, probability that both A and B happen. Okay, P of B is nothing but the probability of event B occur. Okay, these are the main terms in this. Okay, now let's discuss few two important things. Okay, so if I'm saying what is the probability of event A occurring given B has already occurred? So let's say if I say if A and B are independent events, okay. So do you think B probability of B can impact the probability of A? Try to imagine this scenario. We discussed about it, definition of independent events, right? So the probability or the occurrence of A cannot affect the occurrence of B. So it does not matter, right? What has happened if B has already occurred, right? The probability of A, probability of event A occurring given B has already occurred will still be of P of A only, because if A and B are independent events, probability of B or occurrence of B will not affect the occurrence of A. Okay. So in that case, P of A by B will be P of A only if A and B are independent events. I can repeat this again if you are not able to understand it. Please let me know. I'm waiting for your response. And please reply yes or no. You understood? Then yes, otherwise no. Okay, thanks, Prashant. This is the old response. I'm waiting for your new response. Prashant, Ashish, Rohini, anyone would like to say yes or no? You understood it? Okay, Prashant left. Cool. Okay, I'm expecting all of you understood it, right? Okay. Now, okay, let me explain it again. Okay. If A and B are independent events, right? Then occurrence of B will not affect occurrence of A. It means P of happening A if B has already occurred will still be P of A because B is not impacting anything about A. Okay. We have to use this formula only when these two events are dependent. Okay. Understood? Great. Now let's move to the next slide. Okay, let me delete this first. Okay, now let's try to solve the example. Example is drawing two cards from a deck. Okay, without replacement. Okay, without replacement means I'll tell you. Okay, let's try to solve the example. We will be seeing what is the replacement. Okay, or what is without replacement. Okay, suppose you randomly draw two cards from a deck of 52. What is the probability that the second card is an ace? Okay, given that first card drawn was an ace. Okay, now you can imagine, right? These two events, right? Drawing a first card and drawing another card are dependent on each other, right? Based on the definitions that we discussed. Okay, so let's try to solve this using the formula that we just discussed, right? Because here we are trying to calculate the conditional probability of event like event A occurring given that B has already occurred, because here we are trying to say that the second card that we are drawing, what is the probability that it will be an ace when we have already drawn one ace from the deck. Okay, so it means there are two events. So event A, drawing an ace on the first draw, that has already occurred. Event B, drawing an ace on the second draw. Okay, so now let's try to compute the probability. So what is the probability of having happening event A? Okay, so PFA will be, so there are four aces in the deck, right? So the first probability will be 4 divided by the total number of outcomes, that is 4 divided by 52. Okay, now let's try to calculate probability of event B when A has already occurred. Okay, so probability of drawing an ace given that ace has already drawn. Okay, so it means like now we left with three aces, right? Because we have already drawn one ace from the deck, right? And if we have already drawn one ace from the deck, right, then we are left with the total 51 outcomes only. Okay, because the number of card left in the deck is 51 only. So P of B, right, when A has already occurred will be 3 divided by 51. Okay, now apply the conditional probability formula. P of B when A has already happened. Okay, like we have already actually calculated the probability, but let's try to put in the formula again. Okay, so now like we are saying, when we like try to say conditional probability, these two events have like has already occurred. Okay, now let's try to put it. So applying the conditional probability formula, P of B divided pi A will be P of A intersection B, okay, divided by the P of A. Okay, so now let's put it. Okay, so what is P of A intersection B first of all? Okay, can anyone tell me what is P of A intersection B? We just discussed, if you remember, guys. First of all, you have to identify what type of events are there. I'll go back. Do you remember this? Dependent events. A and B are dependent events, right? So if I'm saying what is the probability of happening these two events together, right? Because one event affects the probability of another, right? So P intersection A will is nothing but the probability of A into probability of B consider condition is A has already occurred. Okay. So we'll put in this formula. Okay, let me move to the next slide. Yeah, here we'll put in the formula. What is the probability of A intersection B is P of A into P of B pipe A 4 into 52 into 3 by 51 equal to 12 divided by 265. It's a very big number. Okay. So now the probability of drawing an ace on the second draw, given that the ace was already drawn in first, is 3 divided by 51. Okay, that because that we have already have. Okay. Any doubt? If you have any doubt, we will discuss it again. Please answer if you have any doubt. I'll be discussing this again. If you have any doubt, we are running out of time. I want all of you to answer, right? So, as I expected, we were not able to finish this class because we have a lot of pages left, right? So we will continue this in our next session, right? We'll be talking about the conditional probability again because I know you were not able to understand it. Okay, so we will be discussing this conditional probability again in the next class. But please try to, understand these things first, right? Otherwise, you'll not be able to solve it, right? Or properly understand it. Try to, imagine the example of independent events and try to, think about it, right? How to identify independent event. Second, the dependent event, and third is a mutually exclusive event. Complementary event is the simplest one. It's the complement of something, right? Okay. Then the addition rule and the multiplication rule. Okay. Like when addition rule, like we talk about two types of events in additional rule. If it is a mutually exclusive event, so probability of happening A intersection B will be zero. If it is this formula will work only when it is like when we are trying to solve it for the non-mutually exclusive event. Okay. Anyway, it should work because P of A intersection B is zero. Okay, you can use it directly as well. Multiplication rule for independent event. Okay, it's an AND event, P A and B, right? It is nothing but P A into P B. Okay, but it's for the independent event only. Okay, okay, but for conditional probability, like when the two events are dependent, right? We will discuss about it in the next class. I hope all of you understood and like the things that we have discussed before conditional probability in today's class. Okay, so let's end the today's session here. We will talk about it in detail again in the next. Okay, thank you all of you. Thanks for your time. Let's meet in the next session that is on Saturday. Okay, have a nice evening. Thank you. Bye bye.